Hello friends, in this video we will cover compound interest, look at the formula as well as the underlying terms associated with the formula, and then look at how or why exactly people prefer compound interest over regular interest. Alright, so let's dig right in. So we need to look at some of the terms and concepts before we actually start looking at the formula for compound interest. So let's look at who's a lender or an investment holder. You're looking at a lender when you decide to borrow a certain amount of money from a bank. Maybe you're buying a house or what have you, or buying a car. Then you need a lender. In that case, you're borrowing funds and from a bank. The other scenario is when you are making an investment into an institution by depositing a certain amount of money into a bank, and that's when the same becomes an investment holder for you. Based on what we discussed in the previous slide, you as the individual are either borrowing or depositing funds into the bank. If you are borrowing funds from the bank for a loan on a house or a car, then you're a borrower. If you are depositing funds into a bank, then you're more of an investor because you're seeking to receive a certain amount of interest, accrued interest, for the duration of time you've vested your funds in the institution. And in that scenario, you are a depositor. Fair enough. The principal amount is the amount that you either are taking out or borrowing from the lender. And if you are a depositor, principal amount is the amount you have invested in the bank. The term is the amount of time that you want to pay off your loan within, or in the case when you are an investor, it is the duration for which you have invested your money in the bank. So for instance, if you decide to borrow a sum of $10,000 from a bank and you want to pay off the loan within 10 years, then the term is 10 years. On the other hand, if you have deposited funds of $10,000 and intend to get back the deposited amount within 5 years, then your term is 5 years. All right, let's move on. Annual interest rate, R, is nothing but the annual rate of interest, but it's expressed in decimal. So if you have been given an annual interest rate of 5% on your investment, then it is converted into decimal format, which is 0.05. And then N is the number of times the interest is compounded per unit of term. So if in your case, in the example before, if you were looking at 12 years, then N becomes the number of times the interest is compounded per year. So it could be monthly, in which case N would be 12. Alright, so then let's look at an example here, or before we look at an example, let's look at the compound interest formula. The compounded interest plus the principal is determined by this formula, which is P times, in parentheses, 1 plus R upon N to the power, the whole to the power of N times T, where, as we mentioned before, P is the principal amount, R is the annual interest rate expressed in decimal format, T is the duration for which the money is borrowed or invested, depending on whether you borrowed funds or invested funds, and N is the number of times the interest is compounded per unit of time. Now we have the example. So for instance, let's look at what we have here. Daisy deposits a sum of $4,000 in a savings account in a bank at a 2% annual interest rate, which is compounded monthly, and we're asked to find the value of the investment after 10 years. So we have been given the principal amount, which is $4,000. We have been given the annual interest rate, which is 2%, so we convert that into decimal, which yields us 0.02. T is the duration for which the money is borrowed or invested, which is 10 years. So that's given as well. And then N is the number of times the interest is compounded per unit of 12 years. So the number of times interest compounded, it says compounded monthly. Since you have 12 months in a year, N becomes 12. So with that information in hand, we already have the information mentioned here. We insert this in the principal plus compound interest formula, and that gives us 4,000 times 1 plus 0.02 divided by 12, the whole raised to 10 times 12. Once we simplify this, that gives us 4,000 in parentheses 1 plus 0.00167 raised to the power 120, which is nothing but $4,884.79. Please note that this is the principal interest plus the compound interest, which is the value of the investment after 10 years. If you were to determine just the compounded interest, then you'd subtract the amount, the principal interest amount, which would give you the remainder of $884.79, which is the compounded interest Daisy yields after a period of 10 years. If in the previous example, if you had instead of $4,000, if Daisy invested $10,000, then she would have made $12,211.99 after 10 years. So that would be the value of her investment after 10 years, and the compounded interest she would have earned would be 12,111.99, subtracting 10,000 from it, which would yield $2,211 in compounded interest. If instead of 10,000 she had invested 20,000, then she would have yielded 24,423.98. And instead, if she had invested it over a period of 20 years, then that same $20,000 would have yielded her $29,826.56. Now let's look at this calculation when we plot it in a graph. What you see is you have three different bars that I have plotted. The green one is for the principal amount, the orange or the yellow one is for the regular interest with no compounded interest included, and then the orange bar is for when you have compounded interest included as well. So as you see, the compounded interest is always more than what you would have made with just regular interest being accrued. So the bottom line is that compounded interest earned has its benefits, and it's always more than what you would have earned otherwise. So always look for institutions or organizations or banks that are providing compounded interest. Look at the rate that they're providing. The higher the rate, of course, the higher will be the yield and the amount that you would earn after a certain amount of time. Of course, the longer you invested, the more is the amount that you will make after that period of time ends. So it's an exponential curve in case of a compound interest from the amount of money that you make versus the interest that you would make with just no compounded interest would be much less, and it's not exponential. So compounded interest, like I said, has its benefits, and that's why many investors look at banks that provide compounded interest. So that's it. Thank you very much. If you enjoyed this video, please give your thumbs up as well as subscribe to our channel. Thanks.